So here it says the probability of A and B can be calculated, and this is the math we did on the previous page, ending up with a simplified total of 5/18. I do want to say it says one on a single roll of 2 dice, the probability of rolling a sum or a double is, this is no longer 1/36, that is a typo on that. That should say 5/18. Okay. Example 3 says use of the addition rule for probabilities. The table below shows data from an experiment conducted to test the effectiveness of a flu vaccine. If one person is selected from this population, what is the probability that that person was vaccinated or contracted the flu? Write your answer as a percentage rounded to the nearest tenth. So let's look at what they want again. Let's reread the problem. It says, what is the probability that the person was vaccinated or contracted the flu? So here we have two separate things. We have the probability of vaccinated or contracted the flu. So let's look at the first one. The probability that they were vaccinated. We have a total of 219 people that were vaccinated. Now let's look at those who got the flu. If we look at the flu here, we have a total of 97 people who got the flu. But if you notice, the very, very important area, which I highlighted in red, are those who contacted the flu and were vaccinated, okay? So there is an overlap between these two sets, so I can't simply just add the total probabilities together. I also need to subtract off what they have in common. So again, the probability for vaccination was 219 over the total. Probability of vaccination was 219 over the 490. We're going to add to that the probability of the flu. So how many people contracted the flu was 97 of the 490. But then we need to be careful. We need to take away the probability that they were both. Those who had the vaccine but still contracted the flu. Looks like that's a total of 21 of the 490 people. So if we put that together, seems to me that we're getting about 59 over 98. Again, though, I hate these fractions, simplified fractions. That's what my calculator gave me. I hate simplified fractions in real-world problems because the 59 over 98 really gives me nothing. So on this problem, I'm going to reread the question and look, and it actually says it wants us to round it as a percentage rounded to the nearest tenth. So if I approximate this as a decimal, I would get 0.602, but that's not a percentage. As a percentage, that is 60.2%. 60.2% would be the final answer to the problem. That is our answer written as a percentage. And again, on the majority of the real-world problems where we actually have the data, a percentage would be the best way of writing the answer. Let's check example 4. It says the data in the table below shows that the starting salaries of college graduates with selected degrees. If one person is chosen from this population, what is the probability that the person has a degree in business or has a starting salary between $20,000 and $24.99? So let's take a look at these two things. It wants the probability that the person has a degree in business, so I'll just write BUS, or that they have a starting salary of 20 through, I'm just going to say 25K. That's not really what it is. It's $24.99, but there it is right there, okay? So let's look at this. It's the word or. Anytime I see the word or, I'm going to think of addition. So I need the probability of business plus the probability of the 20 through the 25,000. But then I always have to subtract off the probability that it's both. Let's take a look at our chart and see what we have. The probability that they were business. Well, there's one bad thing about this chart. This chart has no totals. I'm going to go ahead and add every single row together and every single column together to get my totals so I can do the total probabilities. Please do that now as well. Please check my totals now to see if you got the same thing as I did. But I'm getting a total business is 98 business degrees out of a total of 206 is what I was ending up with. Then I looked at the probability that they had a 20,000 through $24.99. That was 39 of the 206. So a probability of 39 over 206. But then I need to look, what do they have in common? The probability that they were both was 16 of them. So I have to subtract off that total which is the 16 over the 206. Put that together in your calculator, and I'm ending up with 121 over 206. Again, I don't want to simplify this fraction because there were 206 people. I'm saying 121 of them were there. I'm going to reread the problem to make sure it doesn't say what form it wants the answer in. I don't see anything that says write it as a decimal or write it as a percentage, so I have to presume they want it as a simplified fraction, even though in the real world you'd probably produce this answer as a percentage.